final method of integration is called integration by partial fractions. There are several cases one has to consider, but let's just do the simplest case. So the example I want to do is how to integrate from x naught to x of ds over s times 1 minus s. So the difficulty here is that the denominator then is a polynomial. So then we're actually trying to integrate here a rational function. So the partial fraction decomposition is what we need to use. So for the more complicated cases, you can look this up, say on Wikipedia. So the partial fraction decomposition writes 1 over s times 1 minus s, this integrand, as a divided by s plus b divided by 1 minus s. So when these break up into these monomials, you can always write it like that. We can find a and b. There are two different methods. One is to just put it under a common denominator, but there's an easier method, which is called the cover-up method, which is worth learning. So the idea is as follows. We can determine a if we multiply both sides by s and then set s equal to 0. So if we multiply a over s by s, we just get a. If we multiply b over 1 minus s by s and set s equal to 0, we get 0. So the right-hand side will just become a. Then if we multiply the left-hand side by s, we cancel the s. We set s equal to 0, we get 1. So just by looking at it, we can immediately see that a equals 1. Then we apply the cover-up method to get b. We multiply both sides by 1 minus s now, so the right-hand side becomes b. We multiply a over s by 1 minus s and set s equal to 1. So then this first term will be 0. We multiply the left-hand side by 1 minus s, set s equal to 1, and we have 1 divided by 1. So in this simple example, b is also equal to 1. Okay, now we're ready to integrate. So instead of integrating 1 over s times 1 minus s, we're going to integrate 1 over s plus 1 over 1 minus s. So let's write the integral. We have the integral then from x naught to x of ds over s times 1 minus s. So that will become the integral from x naught to x of 1 over s, so ds over s, plus the integral from x naught to x of 1 over 1 minus s, so ds over 1 minus s. Okay, because of this then reduction of the denominator to just a single monomial, we can integrate using logarithms. So the integral of 1 over s ds, right, x naught and x are between 0 and 1, is just the logarithm. We don't need the absolute value sign. So it's the logarithm of s evaluated between x naught and x. And then the integral of 1 over 1 minus s, this is still positive because s is between 0 and 1, is a logarithm, but we have a chain rule here, so it's a minus the log of 1 minus s. So this is minus the log of 1 minus s. And that's also between x naught and x. When you have limits on the logarithm, we can use log of x minus log of x naught is the same thing as log of x divided by x naught. So we can jump to that directly. So this is log x over x naught minus then the log of 1 minus x minus the log of 1 minus x naught is just the ratio. So it's the log of 1 minus x divided by 1 minus x naught. Okay? And then again, we can combine these two. Because of the minus sign, the denominator here goes in the numerator, and the numerator goes in the denominator. So that becomes the log of x times 1 minus x naught divided by x naught times 1 minus x. Okay, and that's our integral. Okay, so let me review. So integration by partial fractions is an attempt to integrate rational functions. So we might have complicated denominators. If the denominator is simple enough, then it's easy to do a partial fraction decomposition. So I take a very simple example to integrate ds over s times 1 minus s. We do a partial fraction decomposition. It's very quick if we use to find a and b if we use the cover-up method. Then we integrate, we get logs, and we can combine everything together. I'm Jeff Chasnov. Thanks for watching, and I'll see you in the next video.